So at the end of the last video, we considered the possibility of finding the exact value of the sine of 13 pi over 12. Now, you could have done this a number of ways. I went ahead and I broke the 13 pi over 12. First I converted it to degrees and broke it down as 1 to 50 plus 45. You could have used a sum or difference of two other angles, but hopefully in the end you ended up with these values right here for the sine of 13 pi over 12. Okay, so in this video we're going to take a look at what are called the double angle identities. So take a second to write those down if you need to. And the way that these work is not only we changing the trig functions from one side to the other of the identity, but that angle is also changing. You can see on the left side for all three of these identities where our argument is a 2 theta, whereas when we move over to the right hand side, now we're just looking at theta. A quick explanation of this, or to sort of visualize how this might be working, is to consider, well, let's use the sine of 2 theta 1 as an example. Let's say we had the sine of, let's say, 120 degrees. Using this identity, we could say, well, 120 degrees is 2 times 60 degrees. So if we thought of that as the sine of 2 times 60 degrees, we could use this identity, and this 60 now becomes the theta that we use on the other side of the double angle identity. So this would be the same as 2 times the sine of 60 times the cosine of 60. So we're not only changing the trig functions, we're also changing the angle that we work with. So this was our 2 theta, and the 60 degrees in this example was the theta. And sometimes this is really helpful for us to be able to do, to change the argument inside of the trig function. So with that in mind, that's kind of how these work. And now we're just going to do a few examples here. So let's try this one first. So let's suppose that we're dealing with some angle theta, and that the terminal side of that angle theta goes through the point 4, -3. Now this is not a scenario we're unfamiliar with. We've done problems like this in 10.2 and 10.3, this idea of a side going through a particular coordinate. But here we're asked to find the cosine and the sine of 2 times theta. So lots of common steps here, but we do need to use these double angle identities in the end. So here's what I would recommend. These are the steps that I'd recommend that you take as you work through this one. First thing you want to probably do is go ahead and find the sine of theta and the cosine of theta. The reason we're going to want to do this is if you look at the identities, they all involve just theta. We get rid of the 2 theta. So if we can find the values of the sine of theta and the cosine of theta, we can use them in these identities to get values for the cosine and sine of twice of theta. So once we get these values for sine of theta and cosine of theta, we're then going to use the double angle identities. So use the double angle, and then I'll just abbreviate this IDs. Okay, to kind of get an idea of what we're looking at here, I'm just going to go ahead and I'm going to sketch a quick graph. And sometimes this is really a helpful thing with these problems when we're talking about angles of rotation and points on a plane, is to get a reference. So I'm just going to draw a quick XY plane. So this is our x-axis, this is our y-axis, and we know that we've rotated to the point where we've got our terminal side going through the point 4 on the x-axis and -3 on the y-axis. So that's our terminal side. It's rotated around, and this is theta, not 2 theta. That's our angle theta that's rotated through, and it's going through this point right here. So let's address this first step of finding the sine and the cosine. If you don't see why that's a good first step, you will in a second here. Now the way that I'm gonna do this, and again you could do this a number of ways, is I'm going to use the fact that we can define sine and cosine in terms of x, y, and r. So for step 1, I know that the sine of theta is defined as y over r, and the cosine of theta is defined as x over r. So if I can find x, y, and r, I'm golden. I'm in perfect shape. Now, we've got a few of these already. We know that x is equal to 4, because that's the x coordinate that our angle theta is going through. That's our x. We know that our y is equal to -3, because that's the y coordinate of the point that its terminal side is going through. So all we really need is we need to find r. And if we keep in mind the fact that we're trying to find this radius, and that r squared is equal to x squared plus y squared, we can use this to calculate r. So we know that r is going to be equal to the square root, and r is always positive in terms of this course, is going to be equal to the square root of x squared plus y squared. And that's going to give us a value of the square root of 16 plus 9, or the square root of 25, which would be equal to 5. So now we've got our r. We know that r is equal to 5. So now let's go ahead and get our values. So sine of theta is going to be y, which is -3, divided by r, which is 5, and cosine of theta is going to be x, which is 4, divided by r, which is 5. So now we've got this information to work with, and this is really crucial information for us to solve here. So for step 2, we're going to use the double angle identities to find the sine and the cosine of 2 theta. So let's first, and I'll dub this with a little I, is first one we're going to find is the cosine of 2 times theta. So we've got some options here. We've got 3 different identities that we can use for the cosine of 2 theta. I'm just going to pick the second one. You could use whichever one you want, but I'm going to use the second one. So I know that this is going to be equal to 2 times cosine squared theta minus 1. And just for notation's sake, we'll give the alternative, which is the cosine of theta squared minus 1. Now we know cosine of theta. We just found it right here. So we know that the cosine of theta is going to be 4/5. So we're going to use that in solving this problem. So this is going to be equal to 2 times 4/5 squared minus 1. And if we work this through, this is going to be equal to 2 times 16 over 25 minus 1, which is going to be equal to 32 over 25 minus 1, which is going to be 25 over 25. And that gives us a value of 7/25. So that's the value of cosine of 2 theta. So now we've got to find the sine of 2 theta next. So I'll make this double I. So now we find the sine of 2 times theta. Well, we use the identity. We've only got one to choose from here. So that's 2 times the sine of theta times the cosine of theta. And we know the value of both of these. We found it in step 1 here. So we know that this is going to be equal to 2 times the sine of theta, which is -3/5, times the cosine of theta, which is 4/5. And we just multiply all this out. And when we do, we're going to get 2 times -12/25, which will give us -24 over 25. And that's the value of the sine of 2 theta. So using those identities and by finding that sine and cosine, that's crucial to be able to do this first in problems like this. Then we can just plug those values into our identities. I'm going to follow this up with a question. I'm going to ask, well, what quadrant is 2 theta in? So we know, looking at our sketch, that theta is in the 4th quadrant, but what quadrant is 2 times theta in? Well, we could answer that question by looking at the fact that the cosine of that angle, 2 theta, is a positive number, and that the sine of the angle in question, 2 times theta, is a negative number. So what quadrant is the cosine positive but the sine negative? Well, we know that this is going to be quadrant 4. So quadrant 4. Because that's where our cosine is positive and the sine is negative. So this is the type of problems you might run into with the double angle. The one that I'm going to have you guys try for the next one, and this might be a little bit tricky, but I think you can handle it. So let's try this one for next one. So try this. Let's suppose that the sine of theta is equal to negative 12/13. Okay, so that's our information. That's theta. If we know that theta is in the third quadrant, so in quadrant 3, I want you to calculate the cosine of 2 theta and the sine of 2 theta. Now what we're going to have to do here is we're going to sort of have to trust our method here. So remember that first thing that we had to do is find the sine and cosine of theta. Then we can apply the double angle identities. Well, the nice thing is I've kind of already done half your work for you. So with that piece of information, go ahead and try this one, see what you get, and we'll take a look at the answer in the last video.